So let's continue. We need to finish off this function actually. Again, it should count to neighbours. We'll go through each index at a time, counting the neighbours. And fails. So let's just spread this apart. Yeah, because we're only referencing 3. So we need to pass the previous column, -1. Yeah, that passes. So we'll just duplicate this actually. So index of 2. That fails because we're not doing the previous, the column above, minus width. Yeah, that's fine. And then we'll duplicate this again. So this time it should return 3 neighbours. So this is the last index, 3. And that fails. So we only got 2. We're getting the one to the left, a 1 to the right, a 1 above, a 1 above, and to the left. Yay. Yeah, that's a good start. So we've only got 6 cells, 6 neighbours that we're checking. So the next test would be to increase the grid size, because we actually want to test a square root of 3. So that's 9 cells. So we want to take 0, 1, 2, 3, 0, 1, 2, 3, 4, index of 4. Yeah, so that fails. So because we're doing columns, it will have to be the column to, this is a column to the right, the left. Now we want to do to the right, so we need to add 1. You save that, and then that actually breaks some of the other tests. Now this is because if we have a small square, actually not necessarily a small square, but if a cell is in the first column, then if it goes back 1, it would actually loop to the row above. So we've got some overlap to handle here. So let's go and get started. One way we could do this is we could use a modulus operator, and we could say index modulus width. So if this is not 0, then we can access the cell. If it is 0, then we just default to 0. We can go ahead and copy and paste that on the other left column. So any left column has a -1 in it. So we just paste that in. And actually now we can do a similar thing. We want to detect if it's the end. So if it's the end, that means it is 1 less from the next line, if that makes sense. So what we can do is we can say if we add 1, that means the next line will be overlapping. So we can go ahead and just paste and do the same things. Hey, excellent. All our tests are passing with 100% coverage. So let's go ahead and refactor. I think I'm just going to create a helper function, left column values. Anything in the left column, which has a -1, I'm going to go ahead and sort of group these together. So we can distinguish, because these on the left column have -1 and these on the right column have +1. So we can basically, so this is duplicated. So let's say, let's use a ternary. So we've got index width, cells. So let's just put that in. So this will have to take an array, sorry, return an array. So we'll have to destructure the array. Excellent. So we can just repeat the same with the right column. Hey, excellent. So this is a lot cleaner. We can see why we've separated these out, because these are column values. So left column values, right column values. So this is actually communicating to the developer what these values are. You don't need to write comments all over the place. The code should pretty much tell you what is going on. So for example, take the regenerate. Regenerate cells is alive, cell, and count neighbours. So this pretty much tells you what is going on. So that's what we want. We want clean code where the functions are not too long. Each function is doing one thing,